first topic for basics of civil engineering on the field of statics is magnitude of resultant R with the formula R equals square root of Rx squared plus Ry squared. As I have discussed on my blogspot, the magnitude of resultant R is an important factor on civil engineering because it will be one of the foundations in further computations. Here is an example problems on the application on solving resultants. Here's the problem. Number 1. Determine completely the values of R for the forces shown. Here is the figure wherein we have three forces, wherein the first force is equals to F1 equals 100 Newton. The second force equals to 500 Newton with the slope of 3, 4, and the hypotenuse of 5. And the third force equals to 200 Newton with an angle of 30 degrees. First, we should first consider the remembering of positive and negative. Now remember, if the force is pointing upward and to the right, we should see the force as positive, and if it's pointing downward and to the left, force is then negative. Now back to the problem. We should, considering the first force 100 Newton, we could see that Rx for the first force, Fx Fx is already equal to 100 Newton. Why? Since the force is already in the x-axis, we no longer have to component the force. Now, for the second force, F2, it's Fx, and we can see the given triangle with a horizontal of 4 and vertical of 3 with a hypotenuse of 5. You can compute for the Rx by the equation 500 times 4 over 5. Now, why didn't I use angle like this? Remember that if we have a triangle, we can use example for this figure 4 and 3, 5. If we need the x component, we can use 4 over 5. And if we need the y component, we can use 3 over 5. Therefore, for x, for y, if this is the values given. Next, we can see that the x component of this is pointing to the left, therefore the value would be negative. Next force is the force at third, Fx. Here we can see we need this value of Fx. We have the value of the hypotenuse and the angle. Therefore, we need the opposite since it is the Rx of force 3. By using the basic trigonometric function sine, we can compute for Rx by 200 sine 30 degrees. We can compute for Rx by summation of Fx is equals to positive 100 minus 500, 4 over 5. You can also see that the Rx at the third force is also negative, minus 200 cosine 30. And compute for Rx equal to negative 400 Newton. Next, we should now consider the value of Ry. Since the first force is already on the x component, we could say that the value is already equal to 0 or non-existent. Now, Ry. For the first force, 0. For the second force, positive since pointing upward, 500, 3 over 5. For the third force, 200 cosine 30 degrees. Why cosine? Since we have the hypotenuse, the angle, and we need the adjacent, therefore using the ka from SOHCAHTOA. We could then compute for Ry by summation of forces y, which will be then equal to 126.795. By the way, you should also remember that this is negative since force K is negative. Now, to compute for the magnitude R, you could say that Rx squared plus Ry squared is equal to square root of negative 400 squared plus 126.2795 squared. Therefore, our magnitude resultant R is equal to 419.615 Newton. Therefore, this is the final answer.